The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Welcome, everyone, to the Lighting Controls Podcast. We've got a great guest for you today, Mitch Hefter. He's going to talk to us about standards, standardization, and all that other dry stuff. And hopefully it's going to be not so dry in this episode because he's got some really great information for you. But before we get into it, just want to let you know that this podcast is presented by the LCA, the Lighting Controls Association,
and financially supported by NAILD, the National Association of Innovative Lighting Distributors. And please do not forget to check out Lighting Controls Podcast for all of your sweet merch, to get information on additional episodes. Check out our social media, anything else you'd like to see, previous episodes, and you'll hear reference to a couple of our previous guests in today's podcast. So be sure to check those out as well.
All right, welcome back, everyone, to the Lighting Controls Podcast, where we just love talking about lighting controls, and that's the only subject that we ever talk about. Not really. But today we've got a great guest, Mitch Hefter. Mitch, do you mind just giving us a quick breakdown on who you are and what you do?
I'll give it a shot. My day job is I'm a senior systems engineer with Signify, where I design lighting control systems, most often in the architectural areas, but I have a strong involvement with entertainment lighting. That's where I really started in this industry, and I am involved in various standards organizations, including dealing with the National Electrical Code and ESTA and IES. So do a lot of work in the standards in those areas that feed back into supporting what we all do.
Well, thank you so much for being with us here today. I think you bring a wealth of knowledge and experience to the industry, and I think your involvement in developing these standards really stands out in my view of what you've done throughout your legacy. But it's also just all the things that you bring to the table to our industry are really important to the lighting controls conversation at the very least. So, it's really great to have you here to talk about this. And I'm just curious, what your view of lighting controls is for our industry. Where are we? Where are we heading?
Oh, you want me to get philosophical now?
Yeah, the big question.
For a brief moment.
It's constantly changing. Obviously, the technology is taking us to new places. Wireless is growing in the architectural industry, starting to get down to luminaire level controls. We've been able to do so much more. I remember when I started, everything was analog signals. And then we went into digital, including the development of DMX512, which when we were developing that, no one thought it would end up where it is today. But now
I'm going to put you on the spot for that, actually. What was the expectation for DMX512A?
All right. We did it before A, so.
Oh, that's right. It was DMX512.
Yeah, so it was back in 1986 is when we started this project. There was, at that time, it was an engineering commissioner for USITT, and we were dealing with programming for the 1986 conference in Oakland, California. And I can't remember exactly how it got started, but we set up a session for dealing with some kind of common protocol, a lowest common denominator. Because at that time, pretty much the systems were locked in. You had manufacturer A could only work with manufacturer A's console. Their dimmers could only talk to each other if they were doing anything beyond the most basic analog form. People were starting to come up with the digital protocols. And there was a desire to not necessarily rule that out, but the rental houses, the dealers, were running into issues where something happens. I mean, you're out on a tour and something gets damaged, and now you can't if you don't have the right console with you to run the dimmers or vice versa, you were in trouble. So we had a session to discuss this and how do we approach this. And at one point, some of the dealers got up in front of the room and held up the papers and no more orders till you guys figured this out. At the front of the room we had about 10 engineers or principals with the dimming and controls companies. And at one point it was brought up that, hey, here's a protocol that exists. It was color trans digital protocol. It was fairly basic. And he said, well, we all know what this is. What if we do some changes to it that nobody gets an advantage or disadvantage? In fact, the first company that came out with DMX512 was not color trained. So some of the products came from elsewhere. And that's really what resulted from the session. We were going to go put our heads together and develop a protocol that would be the lowest common denominator. So you may not get all the bells and whistles that you got with your proprietary protocol, but you can run things. And for a lot of applications, that's all you need. But the expectation was, yes, it's lowest common denominator. Lo and behold, that was not the case. Now, first thing is the conference was in April and we published the standard in August, which for those in the standards world these days, it's actually not really possible.
Lightning fast.
Well, we weren't doing it through an ANSI process. It didn't meet the official ANSI muster, but I think we had a pretty good cross section. And so that was published, and then we discovered, we maybe pushed things a little bit, and there were some implementation issues, and so the 1990 revision came out, and that's when it started to take off. But again, nobody was expecting it to be more than just from a console to a dimmer rack or a desk to a dimmer rack. Right. That's how it was originally conceived. But everybody started going there. The moving light companies went from their proprietaries and started implementing DMX512. And it took off from there. And we were sailing along until about 1998. And got to notice that DIN, Standards Organization out of Germany, had developed their own version because they needed something that was officially recognized by a standards body, or an official standards body, which USITT was not. It was something we were talking about, but we weren't in a position to do that. The problem was they said, and we're going to call it USITT DMX512-1990. But there were some minor differences that they did, mostly in dealing with some of the hardware interface, which meant it could cause some compatibility problem. And so needless to say, we were a little taken aback at that. They said they'd gotten permission from me. It was like, I would have remembered a call from Germany. They did not talk to me. But so what we decided to do is USITT actually transferred the maintenance of DMX512 to ESTA, which at that point had established the technical standards program that began in 1994, and the ANSI accreditation came very soon after that. And so that's how it became known as ANSI E1.11 USITT DMX512-A. So, because we did do some minor difference. It was backwards compatible. So if you were compliant with the original versions, it would run, but we added some additional features and options into it. We defined topologies, options a little better, marking requirements. And, it was a change. It went from a 5-page standard to about 60 pages. So there was a lot going on. It took us a few years to get it out, but now we have it as an ANSI standard, which I think continued the growth. We did another adjustment a few years later, and it's been reaffirmed ever since. We're actually coming up on, we have to go through the reaffirmation process again.
Mhm.
And we're looking, there might be a couple little tweaks we want to do to continue that compatibility and address
Sure.
all that goes on around that. So that's a
And
very
so,
brief history.
brief history of DMX Part 1.
Yeah.
I love it.
So, you volleyed a bunch of acronyms or
Okay.
initialisms really at us, and I want to
Mhm.
make sure our listeners understand what it is that you said. So, I mean, the very first thing here that I'm sure a number of people who aren't familiar with, what does DMX512 refer to?
All right. DMX, it's is digital multiplex.
Hmm.
So, I mean, we have a pair of wires and a shield that carry 512 bits, actually 513 bytes of data. It's framed byte. We can get real technical there, where I will get in trouble. So, but basically 513 pieces of information in a packet. One's a start code that can indicate what's following, sort of like a header that you'll see in Ethernet or other types of protocols.
Sure.
So we have that. So 512 pieces of data after that start code, and so that's where that comes in.
And the
At the same
512
time,
And the 512 just refers to, if you're thinking about it in terms of lighting specifically, that's the number of addresses per universe that you have available to you. So
correct.
along that string, you're going to have
Hmm.
each address has its own status, and that status is on a value of 0 to 255.
Correct. And again, using some of the alternate start codes, if you wanted to, you could change that 512 to 256, but then they have 16 bits instead of 8
Mhm.
bits. So there's a number of start codes that some of them deal with some proprietary implementations. Some are used because we could run out, so there was changes made. So one of the start codes means the next piece of information is a manufacturer ID to do more of that. So that gives us the expansion. Thankfully for ESTA, when ESTA took over, they kept track of the start codes.
Mhm.
Prior to that, Steve Terry of ETC, originally then Production Arts, and I kept a copy in her desk drawers. And somebody would request one, and we write it down, double check with each other that we weren't overlapping, and went forward from there. But once ESTA got fully involved, now you can actually get all that information from the ESTA Technical Standards
Mhm.
Program website.
And so ESTA is another acronym that you used.
Right. ESTA is the Entertainment Services and Technology Association. It's a trade association that started life as the Theatrical Dealers Association in the 80s. In 1994, it was there was a desire to do more in the standards. So we learned from the benefits of creating DMX512 and a couple other standards at USITT. We needed to take it forward and get that. Even before we had the issue with DMX512, get ANSI accredited standards available to the industry. So at that point, the TDA said, let's do this. I think we have a structure, we can make this happen. They made changes to the bylaws or charter. I don't remember the exact terminology to allow manufacturers to become members instead of associates, and then began the process. So the name changed from TDA to ESTA.
Mhm.
From there, we developed the programs. It took a while because there's a process to go through the accreditation. The technical standards program has meetings several times a year, and we work on development. There's several working groups within that, but ESTA does a lot more besides just the technical standards program. The technical standards program was the genesis, I guess, of several other things, and that's how ESTA came to being. But it is a trade association, so it does work in those areas. The Entertainment Technician Certification Program also came out of that, which is related to that. That came about because items in the National Electrical Code says you can do some of these things, but you need to be qualified. And so the question is, how do you determine someone's qualified?
Right.
There's a number of ways. There's OSHA definitions and all that.
Mm-hmm.
But again, we're a very specific area. So
Yes.
the Entertainment Technician Certification Program came out of all that, and you can get certification as an electrician, a rigger, and a couple of variations within those categories, and that helps. That if you have to prove to your electrical inspector you're qualified to do these unusual items that the code says you need to be qualified, here's a way to do that, and that's been a very successful program as well.
And then one other initialism you used was USITT.
Yeah. Yep. United States Institute for Theater Technology. That was established in, I believe, 60. Yeah, it was 1960. If I remember, it's 60 or 61. I should know this.
Yeah.
Wow.
And it actually started a little more manufacturer based, but it was exactly that, to work on developing information, sharing information on the technical side of theater. And so, 60 plus years old now. In fact, just had our last conference last week in St. Louis, which was a fantastic time. Back up to full strength after the pandemic. We just had
great.
It's one of the most favorite times of year for me, just to be out there and share information, and you get to see a lot of people, and a lot of the members are young college students or young professionals, and the energy level you get there is fantastic. It's just a great exchange of information, and it covers all sorts of areas within technical theater.
Yeah, no, I think anybody in the theatrical world knows the USITT conference and thinks of it as sort of a good jumping off point for career initiatives.
Absolutely.
But yeah, so I mean, we basically looking at the history of all of this stuff building up to where we are now. So you said DMX isn't really used with what the original optics were, which the point of the original purpose of DMX512 was to prevent this, competitive proprietary system, and the dealers basically said, we're not doing this anymore, fix it, come up with an open standard, because this is ridiculous.
Yes, and I think we all can agree that went very well. I remember being in the room, and some of the sales and marketing people at the back of the room were going, "Oh, I don't know about this," and I think the industry took off. It was a key development, and I think everybody's benefited from that. And again, we've now created a number of standards. ESTA has we're into the 70s. Not all those standards or recommended practices are done yet, but that's a lot of items, and what are we at, 30 years now, so 30 plus years.
Yeah, we had Javid on at one point when when a few of your standards were out for public review. And so the wealth of knowledge and documentation within ESTA's standards is really phenomenal and beneficial to the entertainment side of things, but also it follows through into the architectural side of things if DMX is a consistent protocol. And it really is kind of becoming ubiquitous in certain regard, for instance, with color changing fixtures. And so I imagine that the permanent installation function was never part of the original scope of DMX512.
Yeah, it was again. It kind of was, but we knew, it was definitely started out from dealers who were not doing as many permanent systems as many of them do these days, would be my guess.
Right.
I was on the manufacturer side at the time, but so yeah, again, lots of benefits from that. The Ethernet standards that we have, those, ACN, streaming ACN, that's how we can do a lot more universes these days. Universe being, considered a 1 to 512 signal. I remember that this was kind of entertaining when we were working on E1.11. One of our members happened to also be an amateur astronomer, and he pointed out that the term universe is you can't have multiple universes.
Right.
The term had been created. Adam Bennett, who wrote the first recommended practice document on that, I believe he created that term. And I said, yeah, Paul, you have a good point. But remember, we are in the entertainment business, the world of make-believe and fantasy, which does have multiple universes. So I'm not putting that forward. And he said, I had to try. So yes, we have multiple universes. That's what
Were there other proposed terms other than universe?
No, I mean, when it was put out in that recommended practice, everybody seemed to adopt it pretty quickly. So,
Sure.
And I've seen that term used in DALI. So, I don't know if they got it from us, but,
Probably. I mean, DALI is usually referred to in loops. You have a DALI
Yeah.
loop.
Mm-hmm.
But I can see why
which
people
is
would
actually a bus, but that's a different discussion.
Yes, agreed.
Yep.
Well,
Yeah.
actually, out of curiosity, do you mind just going a little bit into detail the difference between a loop and a bus? For our
Can I
listeners?
pass?
All right, fair enough.
I mean, basically a loop, and you'll see this in some wiring. I mean, you will come out of your source and eventually come back. I mean, token ring, which is not something I've seen for many years, it is a digital communication protocol, and that does rely on a ring or a loop, where the bus just goes straight out, and so it's just going from point to point. Now in DALI you have, and some other protocols, you can branch off, and there's not an issue depending on certain things like the data rates that you're transmitting and stuff. May make a difference on how far you can stub off. I mean, DMX512, you're not supposed to, but you always have, essentially in the equipment, you might have a coupling stub, and sometimes you can get by with more. But you got to be careful because of the speeds and reflections. That's why terminating the line is important. And you have to do that with some of the higher speed stuff. So there's a lot of stuff which is not my strength. So when I get too detailed, I say, here, talk to this person. They can explain it better.
That's perfectly fair. I mean, ultimately,
Yeah.
the difference between a bus and a loop is a
Mhm.
bus, you've got two lines and they're running out and it ends,
Mhm.
like you said, and it doesn't loop back. In a loop,
Right.
it's usually one line that just is a continuous circle. And so you don't see a lot of loops nowadays. You usually see
Mhm.
loops in analog or older digital
Mhm.
protocols.
Right.
We have spent a lot of time sort of mentioning the standards, so I did want to just at least let our listeners know, and if you want to jump in, feel free, that
Mhm.
all of the standards that we've talked about are available on ESTA's website. You can go to the technical standards page, and they're all free downloads. You just have to
Mhm.
put in some contact information, an email address. So anyone who's interested in looking at DMX standards, the E131 for streaming ACN, rigging standards, it's all available for free public download.
Yes, absolutely. And sometimes it's easier for me, even though I'm on the Technical Standards Council and I see all these in process. If I want to get the finished document, I have to do the same thing. I do that and put the email address in, and are not likely to get any, marketing emails and stuff. It's in there as a contact, but some organizations you do that and you constantly get
Right.
stuff.
So it's a very low stakes, low investment,
Yes.
just for the purposes of getting these documents. I mean, these documents, if you've read technical documents, you understand them. If you're not as familiar with technical standard documents, they may be a little impenetrable, but definitely worth a look if you're curious.
Absolutely.
Mm-hmm.
Yeah. And just the plug for free, let me as you know, I'm on a couple of panels for the National Electrical Code, and which is under the National Fire Protection Association, NFPA. And if you go to the NFPA site, most documents you can view for free by putting in an email address. If you want to go the next step and have more access, there's a cost involved, but you can view most of those online. It's read only. You can't print or whatever, but that's where you can get your information. So excellent resource there as well. And that's what actually how I got into the standards, where it was started at the NEC level.
And so, I mean, again, we keep gravitating backwards, but going back to that philosophical question of where are we heading? I mean, like you said, there's a lot of wireless stuff coming out, and I know DMX is also on the wireless bandwagon. There's wireless DMX just similarly to how there's Ethernet DMX.
How right now wireless DMX512 is not a standard that ESTA developed. So those are developed by several manufacturers, so they are proprietary. But that does exist, and I've been involved in a couple installations where we were lighting a bridge, and for some of that, it was that final communication to the outer points that was done with wireless, although in that case we were doing it over Wi-Fi, but it was transmitted that way. So it's there's applications of concerts and stuff that's done, and it's so it's out there. It's just right now that does not have that universal standard.
And are there plans for ESTA to produce a universal standard for wireless DMX 512?
Not that I'm personally aware of. If somebody wants to pursue that, you can submit a project proposal, and it gets reviewed, and then the Technical Standards Council and the Control Protocols Working Group will go ahead and consider that. And one of the things that is, you think it's a great idea, have some, make sure you got some people to carry it forward. So, but yeah, if somebody wanted to pursue that, they absolutely could. I think what's more likely happening these days is it's being handled through Ethernet, and so that's probably has made it less necessary to go that next level with wireless DMX512. Although I could be wrong on that. That's not an area I work in very much.
Sure. But yeah, I mean, I think you're right with streaming ACN, for instance. There's just a lot of great options for a hardwired DMX, and that's usually the recommended anyways when it comes to DMX 512 is to do a hardwired connection over a wireless connection.
Yeah, and then again, you have the options like use just Wi-Fi access points, etc. That variation, and so that's how it may be done in some applications. It's going to depend on the particular application, and I will defer to others on the specifics of wireless DMX512.
Yeah, so I mean, and we do a lot with Ethernet now, right? So as an integrator, we do a lot with streaming ACN, with Ethernet, with wireless DMX. I'm actually turning on a job tonight with wireless DMX. So, we use them both a lot. Ethernet especially, as these jobs get bigger and bigger, and you get into the hundreds of universes on some of these architectural projects. You just simply
Mhm.
couldn't do that on a DMX infrastructure alone, right? So Ethernet
Right.
is really where a lot of these larger projects are going. It's so flexible. It's so easy to work with from an end user standpoint. And then, so do you see any big changes down the road as far as how the Ethernet protocols are potentially handled, or anything, heading in that direction?
Well, there's more and more happening with, continuing to develop with Ethernet.
Hmm.
And some of the speeds out there are just, I mean, you're seeing 10 gig, and now they're,
Hmm.
looking at single pair and all
Yep.
those options. Um, in general, the data rates that we need for DMX512 lighting, we don't necessarily need all that, but it's a tool that's there if we do. Um, One thing that came out of Ethernet that was actually, there was interaction with our industry, was the development of power over Ethernet.
Hmm.
And when that happened, there was work with, um, some of the information was brought to the ESTA Control Protocols Working Group. We had the secretary of IEEE 802.3 coming into some of the meetings. Steve Carlson of High Speed Design was co-chair of Control Protocols Working Group at that time, and he was involved. And that's how you saw that one of the first implementations of power over Ethernet was used for the nodes for pathways,
Yep.
Pathport
Mhm.
product.
Yep.
Um, and then others have taken it on, ETC, Strand,
Hmm.
and others all have done that. And so again, that was something that's, some of the first examples, and I've used in presentations, is bring up the picture of the Pathport node. I'm not trying to endorse here. I'm just saying it was the first, but it was there along with actually one of the proofs of concepts. They took a Norelco electric razor and powered it with power over Ethernet. That
Oh,
was
no
one of
kidding.
the
I didn't know
that
that.
was one of the original proofs of concepts. Yep. Yep, that's they
That's
did a
great.
little modification because it had to. You can't just plug it in. There's a little communications routine that goes back and forth. But that was how that was done. So yeah, that's in some of my presentations from way back in the day. Picture of
That's
that.
awesome.
Yeah.
Oh. But yeah, so I mean, as far as the application as it currently is, what are the benefits of having a faster bandwidth or a wider bandwidth with Ethernet-based DMX? Like you kind of alluded to that, but I'm curious if there are any specific examples that you have in mind.
Well, I think one of the uh, most probable thing would be the fact that now I can have a cable or a fiber uh, that's carrying multiple universes. So I
Hmm.
mentioned before we've done some projects with bridges as other people do. Well, those bridges are pretty long. It's a lot
Hmm.
bigger than some stadiums, right? And yeah, we will loop the bridge with, and in that case, we are using a loop. And doesn't have to be, but we often do that. And we have fiber doing that, and then the final communication to the
Hmm.
hardware is done with copper. Um, so you see that. So you have the ability to go longer distances, uh,
Hmm.
and you can have multiple universes on a single or very few cables. If you've got 40 universes, if you try to do that with all DMX512 cable, that's going to be it's going to be a pretty big bundle. And here you
Right.
got something smaller than your fingers. So
It's
So it's
also,
not just. Go ahead.
Ethernet's also really opened the door to having multiple controllers on the same line,
mhm.
right? And then enabling priorities and allowing those different controllers to have control over different aspects at different times by simply changing arbitration and priorities. So that's
Mhm.
really changed what we could do versus just standard DMX, where it was truly an A/B switch, or right, or something to that level, where it was if this one or that one, because it was HTTP, or so really changed
Yeah.
things.
Well, AB switch still exists. It just did a system
Still works.
or earlier this year where that's exactly what they wanted to do. They wanted just
Yep.
that hard break and said, okay, during the event in the arena, we're going to use this controller, and for other stuff, we're going to use this. And they literally have the AB switch,
Yep.
taking
Yep.
particular groups of lights and selecting the controller that way. But yeah, you can do
There's
a lot
nothing wrong
smarter.
with them. Yeah,
Nothing wrong.
I still use AV switches.
Yeah.
I have them on small jobs all the time where I have a simple DMX console and I have some sort of a
Mhm.
wall station, and they truly want this or this. If the console is active, the wall station doesn't work, right? Very, very simple, but they're physically two DMX controllers and one has to win. So,
Yeah. Yeah, I remember the very early days, that was just done with plugging cables. You didn't have a switch. You just pulled it
Yep.
out and then put the other one in.
Right. So for our listeners, I mean, an AB switch just is basically a physical switch that disconnects one line and reconnects another line. So because you can't have two physical processors controlling the same DMX line. Whereas what you're alluding to, Ron, is you can have two controllers on a Ethernet line and
Ethernet.
have priorities dictated in the software to say if this
Mhm.
one, which has priority X, starts speaking, ignore this guy's priority Y. And then also, Ron, what is HTTP?
Highest takes precedence. So if
So
HTTP and LTP, highest takes
right.
precedence and latest takes precedence.
So whichever's brighter gets the precedence.
Yep.
LTP is whoever sent the command last gets the precedence.
Yep.
Yeah, and that's a key difference with DMX512 is that it is a streaming protocol. You know, think of your home entertainment where you're streaming services. It's just one after the other. It's not command based, which is like DALI is command based. It sends a command. So in DALI, you really don't end up with the highest takes precedence. It's the latest takes precedence, although
Mm-hmm.
I'm sure there's some tricks you can do otherwise. DMX512, you'll have mergers, and unless you do certain settings, the merger will say it'll take the highest level, not the last one. But you can get more complicated, and then Ethernet allows you to then dial into other programs, applications, whatever, to have that battle, so to speak.
But yeah, so I mean, also, you said that they do use loops in bridges, for instance, and that's for redundancy's purpose. If you have a break in the middle of it or something, then you don't lose all of that traffic.
Yeah, correct.
So I mean, as far as a loop topology goes, it's technically correct. It's just not the same function that originally would have created a loop topology, but splitting hairs at this point.
Yeah.
A self-healing ring, as others might say.
Yes, thank you. That's a better term that's more appropriate to our modern infrastructure. But yeah, so I mean, there seems to be a lot of innovation around how to carry the data, but at the core level, the data is the same, right?
Yeah.
I mean, you just have more universes of 512, but at the finite level, each universe is still 1 to 512 and 0 to 255 for each address.
Right, and of course, obviously with LEDs and the color mixing, or the moving lights, different channels. So you can't necessarily control 512 lights because your moving light might have, has a number of parameters, pan, tilt, zoom, color, LEDs, depending on how many different colors you're using in the fixture, whether it's could be 1, 3, 5, 7, whatever. That takes up some space. So that's, one of the advantages I guess you get with Ethernet is you have more information to get out there because what would have been a one universe system back in 1986, these days you need more, and so now you have you have ways to make sure that all gets there. I mean, it's still pretty fast, but it's more tools to enhance the craft. It's
Well,
the benefit of the craft, the light,
right.
not the one with the most toys wins type of thing.
Right. Well, and it that brings up one of the arguments that people have when it comes to DALI versus DMX is speed. In art entertainment and architainment, the latency of a protocol can really negatively impact the performance of the lighting. And DALI typically has a pretty slow data stream rate, which causes undesirable results. Whereas DMX, one of its powerful components is the speed.
Yes, and I've seen some stuff, and DALI can be used in the architainment, which is, I'm trying to think that we came up with a different phrase for one of our ESTA protocols with standards and development. I can't remember it right now, but we, depending on what you're doing, DALI may be absolutely sufficient. I'd like to see more DALI in architectural systems. But yeah, if you're doing your live stage show, you don't want to be doing that with DALI. You want to do with DMX512. Use the right tool.
Where would you say the line is then between when DALI is appropriate and when you should really switch over to DMX?
I don't know if I could actually define that, but
Fair enough.
yeah, I mean, if you're doing like a theme park ride, depending on the effects that you're doing, DALI may be just fine. But if you're wanting to have a lot more dynamics in that, DMX512 is going to be your tool, and quite often these days, I think it's going to be under streaming ACN or ACN.
Sure. So, I mean, if the idea is just to hit a button on the wall and to have a static look or maybe even somewhat of a moving look, then DALI's fine. But if you really want like this extravagant multimedia experience, that's when you're looking at DMX for your control protocol.
Yeah.
I think that's a fair position to take, and I would agree with that. I think there's a lot to be benefited, especially in our static white applications, from having a DALI system over, for instance, 0 to 10.
Yeah, and you bring up DALI versus 0 to 10. I mean, 0 to 10 or 1 to 10 is pretty prevalent, and we've talked about that in our IES committee. But again, you have one channel on one wire, so you might have a group of lights in the room that's one, but gee, if I want to reconfigure the room, now I got to rewire that.
Right.
And that's an advantage where if you're using DMX512 or DALI, that's a reconfiguration, and you don't have to change your wiring.
Right.
And we know that in general, the cost of doing a DALI system, the wiring, it's going to be less because you just don't have to run as many conductors. So
and even from a dimming standpoint, 0 to 10 is, a lot of people, I still think, have issue with the fact that not all fixtures are created equal, right? So 0 to 10 does not always mean you are going to get full dimming to off or full dimming to 0 versus fixtures that are DMX controlled, where you have that intensity channel or something else. So I think that's important too for people to understand, is that not all drivers and ballasts are created equal.
Yeah, I was working on a project today looking at the fixture schedule and verifying, they said everything's 10 volts. I'm going through the catalog numbers, and some of those 10 volt systems are 10% and some were 1% dimming.
Yeah.
So,
well, and I think that alludes to what you were saying with 1 to 10 volt versus 0 to 10 volt,
right?
Because most systems work on a 1 to 10.
Yeah, the difference being most people call it 0 to 10, but there's actually 3 different 10 volt protocols out there. There's one that's in the entertainment industry, and that is where the 10 volts is coming out of your console driving the fixture or the dimmer. The architectural is the 10 volts actually resides in the driver or ballast. And your control in the simplest systems can be just a variable resistor, a potentiometer. But most go, when you hit 1 on your scale of 0 to 10, that's minimum level. And to go off, you actually have to disconnect power.
Right.
The latest version of that standard allows an option where you could actually dim all the way to 0, although I haven't seen many implementations of that. So you'll often see 0 to 10 or 1 to 10. Most implementations I still see are actually 1 to 10. And so we created a recommended practice in IES called RP42, and we actually have 10VT is the designation for the theatrical, which is ESTA's ANSI standard E1.3. And then you have 10V being the most common, that's the 1 to 10 volt. And then 10V0 says, I don't need that contactor, I can go to 0. They have the lights go off without having to have that extra relay. So there's still advantages to having the relay for just energy consumption when it's off, but you don't need that to turn it off. So you can have multiple 10 volt channels, if you will, off of one circuit, because when you finally shut down the building, then you turn it off. But for your day-to-day operation, you don't necessarily need that. We'll see that. I mean, it's only been out a couple of years, so I'm sure we'll see more of that.
Sure. Yeah, I think it's becoming quite popular, for instance, with luminaire level lighting controls, where you have an individual controller right in the fixture, and you need to have that granular dim to off capability without actually relaying the whole circuit.
Yeah, and again, some of those will be DALI based, even if it's internally, because they may be wireless to that, and some are 10 volt. So you get a mix of everything there. Keeps things interesting.
For sure. No, but I mean, as far as things go, you've basically got ANSI's standard of 10 volt, and then you've got NEC's standard of 10 volt, or is it NEC or
No. There's so the ANSI ESTA is essentially the theatrical one. That's E1.3. ANSI, and this is through NEMA, and it also coordinates with the European standards,
right, yes.
And I can never remember the number, but C137.1. And that's where it is. The original 1 to 10 volt, which was really meant for just fluorescent and drivers, was an annex to, was it C82.11? It's been so long since I wrote that one down. But C137.1 is the one to look at, and it has both in there.
Yeah, so I mean, they're not compatible with each other, though, because if you're using an architectural version of 10 volt, the driver is providing the voltage. If you're using an entertainment version of 10 volt, the dimmer or the control console is providing the voltage. And there definitely are, you see referred to like sync and source. Syncing is the architectural version, sourcing is the entertainment version. And you'll sometimes see sync/source, meaning that it's compatible with both. But for the most part, they're their own.
And recently I heard of a project that didn't get that difference, and they had some difficulties. And it was not one where the controller, the console, whatever, could do sync or source. So I don't know how that resolved, but it did not go over well. And that goes back to one of the reasons we created RP42 is to try to get some clarity, because I could not look at any of those catalog numbers except about 3 of the 20 fixtures in the schedule and know that it was 10 volt. Looking at that now, I'm not saying the manufacturer, when we develop that, we don't expect the manufacturer to change data sheets and part numbers. It would be nice, but when you go to the data sheet, it's very clear. And the other thing about RP42, so I'm plugging that, but I chair that committee. So a lot of your, particularly your A lamps, I think you've all run into this, it says dimmable.
Mm-hmm.
How is it dimmable? Is it leading edge or trailing edge? Forward phase control or reverse phase control, or both? And again, we tried to address that with the designations in RP42. So what you should see in a data sheet, in my mind, is dimmable dash, LE or UPC, universal phase control, can do either.
Mm-hmm.
That's what we're hoping. So
And I mean, I've read that document myself. It's a very quick read and really worthwhile for anybody who wants to help support this. I think specifiers are the best poised right now to facilitate that change in their fixture schedule, for instance, like you were mentioning.
yeah, if they had just added one column to that fixture schedule, I could have saved a couple hours of time.
Right.
And
it helps with
some do.
coordination.
Yeah,
And
absolutely.
for sure. No, I mean, but I think a lot of people use their own vernacular or their own syntax for that instead of following the RP's recommendation. And granted, it does deviate, when I think of documenting a protocol in the column, I immediately jump to 0 to 10 volt. I don't think, it should be 0, 10 VT or something to that degree. So it'll
get you
work
there.
as a glossary. Yeah, right.
And we also are looking at doing an update to that, so adding some more information and clarity to that after we finish a couple other projects in the IES Lighting Control Systems Committee. So,
Sure.
Yeah, I'll be contacting you.
I'll be here.
Okay.
But we're almost out of time, so I just want to kind of take everything we've talked about. We jumped around a lot, but the sum of what we talked about here really comes down to standardization of the information out there, and that's something that Ron and I keep talking about with other people is, we really need to standardize this. Why isn't there a standard for this? And so there's still plenty of vernacular out there to confuse and conflate and manufacturers don't agree on. But ultimately, there needs to be some group that stands up and says this needs to be standardized. So for instance, taking DMX512 as a example here, it took the dealers, and Ron's a dealer, so I'm sure he can sympathize with those dealers back in the day who said, we're done with this. This is frustrating, impossible to deal with. And so as far as the development of DMX512, originally it was just to develop consensus. And that seems to be the thing with standardization, is it's a way of facilitating a conversation about consensus and making people agree with what should be.
These standards are all consensus standards. It may not be 100%, but it's a consensus standard. And we try to, there's a process to review, get comments, try to address it. You can't address everything in some cases, but we have a consensus, and that works. And same thing with the electrical code, which is same type of thing, consensus on the best way to approach these installation issues, safety related issues. Come up, there quite often there's multiple approaches, and sometimes you have to have a consensus of which approach you're going to use. But that's what it's about, and that's what I find so enjoyable about all this work. And it's some of it's very dry material, but you get to work with a lot of people and have the discussions and come to that consensus, and that's very rewarding.
And also they get revised over time. It's not like it gets planted in stone and that's it. They're living documents that go through a review period. So
right. ANSI requires, in general, every 5 years you have to reaffirm it or start working on a revision, whatever. Same with NFPA. Most of those will be 3 to 5 years, like the National
Mhm.
Electrical Code,
Mhm.
Life Safety Code. That's where a lot of people I know are involved with. Those are every 3 years. So you do get, you always get a look, and all those, you can hit, there's public input. Anybody can submit a proposed change to, let's say, the NEC. We had the last cycle close to 5,000 inputs to the entire code. Now there's 18 panels that divide up that work, but yeah, and everyone gets a look and
Mhm.
feedback and comment. And same thing with the ESTA standards. You got an idea, bring it forth, do it, and then when it's time to reaffirm or renew, announcements go out, and you'll see this in the ANSI. Here's your chance. Give some input. Tell the committee what you're looking for, and they'll address it.
And hopefully somebody listening might want to volunteer for that assistance and jump on these committees, because they're always looking for help. There's
Yeah,
lots of
absolutely.
opportunity.
Absolutely.
So, well, thank you so much, Mitch. This has been an awesome conversation. Maybe a little dry for some people, but it really, personally, I eat this stuff up. So it's
Yeah.
I love it.
Yeah. Yeah. And people have questions or comments, reach out to us. We'll talk your ear off if you let us.
Absolutely. Well, thank you again. Well, that was an awesome conversation with Mitch. I hope you guys enjoyed it just as much as I did. I really ate it up. Great information. Hopefully, we're going to have him back on to talk more about other standards he's been involved in the past as well, and any future stuff coming out. But for now, we'll leave you with what you got. Just want to let you know that this podcast is presented by the Lighting Controls Association, LCA.
And financially supported by NAILD, the National Association of Innovative Lighting Distributors. That was a fantastic conversation with Mitch. I love the history lessons. I love being able to go back to the beginning and sharing that with all of our listeners. So thank you, Mitch. And until next time, guys, have a good one.